In last class, we did discussed about what is the topic? Parameters instantiation, right? So parameters overriding and parameters how we are representing, and then some force and release concept, like means procedural and continuous assignments. Okay, so this topic we were discussed in the last class. So today we will discuss about just give me a minute. So today we will discuss about strengths in Verilog. What is the use of strengths in Verilog? Okay, so that is very important topic. Sometimes we will get the race conditions. Okay, to avoid the race conditions, we need to know these strengths. Okay, what is the use of strength means? Okay, so strength is, suppose two persons, some tug of war is there, two persons having same strength, so then no one will wins the race, right? Suppose other person is having more strength and opposite person is having less strength, means who will wins the race? Okay, so who is having the more strength, so that person only winning the race, right? Same way here also the Verilog provides some strengths, so that is for high impedance and then small capacitance, like this. Okay, so like strength 0, strength 1. Okay, so in that way they are providing some strengths. Okay, so why strengths exist in Verilog? Why we need strengths? What is the purpose of strengths we need in our Verilog? So most of the purpose of strengths is to avoid the race condition, and signals are inactive. Some signals are inactive. Okay, that should be avoided by using these strengths. Okay, most of the things we need to actively drive the strengths. Okay, who is strong in strength, that will be actively driving the signal. Suppose why we these strengths we need to represent means, suppose one driver is there, so one interface is there, this is my one interface. This interface is driving two signals, like two same strength signals. Okay, two same strength signals are driving the same interface, means what it happens, that conflict will be occur, right? Okay, my simulator will not know who is winning the race. Okay, at that time the x propagation error we are getting. Okay, so what is the error we are getting? X propagation error. Okay, so that means if the two strengths are same and then those will be driving the same interface, then the compiler will get conflict. Okay, so compiler will get the conflict, then I don't know who is driving the best signal. So that's why we need to give the strength should be take care of that weak 0 signal or weak 1 signal. So one is less signal, one is having the less strength and other one is having the more strength, then more strength signal will be winning the race. Okay, here two types of signals are there. How many combinations will occur? Four combinations will occur, right? So that means I need to take that two strengths are different. Okay, one strength is different, other strength is different, like one strength is strong, other strength is weak. Okay, in our Verilog, okay, two logics are there, like that is logic 0 and logic 1. Okay, so this one is the two strengths we are having, logic 0 and logic 1. Suppose someone is driving the logic 1 is high strength. Okay. Logic 1 is driving with strength high. Okay. High strength we are driving. Then logic 0, weak strength we are driving. Who is winning the race here? Logic 1 or logic 0? Logic 1 is high, having high strength, logic 0 is having low strength or weak strength, then logic 1 wins the race, right? So here we have different type of operations like AND operation, OR operation, all these things we have. See, what is strength? Strength represents how strongly a signal drives 1 or 0 on a net. Okay, so this is the wire. Okay, this wire logic 0 is there, and then logic 1 is there. Okay, how strongly we are driving these signals on the interface on a net. Okay, that defines the strength. Okay, the signal who is driving from the driver is having the same strengths. Okay, who will wins the race? Definitely will get the conflict, or someone is having see how we will resolve this. Driver means some buses will be tri-state buffers will be used to resolve this multiple driver issues. Okay, so final value will be based on what is the strength. Okay, what is the strength we are driving, that strength, based on that strength only we are getting the final value, either logic 0 or logic 1. Okay, so we are getting logic 0 or logic 1, depends upon the driving strength. Okay, driver strength, who is driving more stronger, that one only wins the race. Okay, so there are some weak signals and strong signals are there. Okay, the levels are given here. See, supply. Okay, here supply is given. This supply is having two values, either supply 0 and supply 1. And strong is also having two signals, strong 0, strong 1. And pull is also having two signals. See, each and every signal is having two types. High impedance is also having 0 and 1. Okay, all these are having some high to low strengths. So first one is having high strength, and the next one is compared to supply, strong is the high. Okay, so compared to pull, sorry, compared to strong, supply is the high, and then compared to pull, strong is the high, and then compared to large, pull is the high. Okay, and compared to weak, large is the high. So in this way, so this is the first one is the highest level, bottom is the lowest level. Okay, and compared to all these things, one keyword is there, that is assign. Okay, a sign is having more strength compared to all these things. Okay, in during the interview, okay, they will ask you. Suppose I'm having my OR gate or AND gate. Okay, I'm getting some output. Okay, that output is having some inputs A comma B. Okay, so then this input I'm getting 1, and then other OR gate also taking, I'm getting the output A comma B. So that output I'm getting 0. Okay, so here what I am explaining here, so these signals will be having some strong 0, strong 1 comma strong 0 is there. That means logic 1 is driving with strong 1, and logic 0 driving with strong 0. Okay, and other one is having weak 0, weak 1 and weak 0. What output I am getting here? These two OR gates are there. Okay, one OR gate and second OR gate. First OR gate is driving the output like 1, and then second OR gate is driving the output is 0. Okay, which output I am getting here? Based on the signal strengths, right? So which one is stronger? See the list of the table here. Strong is the stronger one, and weak is the weaker one. Okay, so then strong is driving the first and wins the race. Then what I am getting the output here? 1 I am getting the output. Okay, similarly here also we are having supply. I told you two types of supplies are there, supply 0, supply 1, strong 0, strong 1, weak 0, weak 1, okay, pull 0, pull 1, all these things. Okay, listen, and what we are using based on this strengths, we are getting some output. Okay, either 0 or 1. So to avoid the conflict, we need to maintain two different strengths. Or if you are maintaining the same strength on the same interface, then what will happen? No one wins the race, and then ultimately propagation error we are getting, unknown propagation error we are getting, right? So just see this. See, strength 0, strength 1. Okay, general syntax, strength 0 comma strength 1. In this way we are setting that value. This is the one example I am giving that. Okay, wire output I'm getting here. This is my wire output. So SIN is the more stronger strength compared to all these things. Okay, so then check the signal strengths here. Okay, what is the signal strength here? Strong 1 and strong 0. Similarly, weak 0, weak 1 and weak 0 I'm having. Here, what is the output I'm getting? My output is 1 and other output is 0. Okay, one signal I am driving with strong one, other signal I am driving with weak one. Okay, who is winning the race here? Strong signal is the winning the race, right? So because strong is the highest priority and weak is the lowest priority, and then so I am getting the output like 1 here. Okay, see, this is the tri-state buffer. Why we are going for the tri-state buffer means, or tri-state bus means, it is driving three values. Okay, one is condition, and other one is true value, and other one is the false value. Okay, so it is going to some high impedance state. So when we are going to the high impedance state means no one is driving the interface means, then it is going to high impedance state. Okay, and don't allow these states and no one is driving the interface is also problem, and too many persons are also driving the interface at the same time, that is also problem. Okay, don't fight each other, stay calm and come one by one. This is not a movie tickets. Okay, if you are first come first serve only, we are getting the first ticket means, that is not a problem. So today everywhere the tickets are available, and then at the first day each and every person they are seeing the watching the movie, right? So same thing will be happen here also. And don't fight the signals each other, and don't give the priority for that. So who is going first, then give the strongest priority for that. And who is going less, okay, give the weak signal to that. Okay, drive the strong signal for one signal and drive the weak signal for the one signal. Then no worries, and one completed, then next one will be going on. Clear? So that is the main motto behind this strengths we are having. See how the conflict will be getting here. See, both are having same strength. Okay, during college times, I'm going first, I'm going first, you wait. So both are fight each other, right? So then ultimately no one will going to going for correction or to meet some other people, right? So ultimately both are lose their opportunity, right? Same thing here also will be happen. Okay, so strong 1 signal is also driving this output, and then strong 1, strong 0 also are driving this output. One output is 1 and other output is 0. Both are important. So because sometimes I am getting the logic low value, then this output 0 is important. So logic 0 is important. I want to get some fail condition. Then logic 0 is important. I want to get some pass condition. Then logic 1 is also important. So both are important, right? So pass and fail both are important. Based on the failing condition, I need to know where is the error in my RTL. Whenever it is passing, I need to know, okay, who is getting passed in my test cases. Okay, that is very much important. Okay. See, here conflict will be getting the output, right? Because both are same strengths. Okay, strong one, here also strong one. Both are driving with the same strength, then output is getting expropagation error, unknown error. Clear? So these are the resolution rules. So rule one, who is the strongest strength, that will wins the driver. Okay. So the same value driven, if same value is driven, strongest strength wins that one. Okay. Opposite values are given, and then compare that strength. Okay. Then one is strong 0 and one is weak 0. Compare the strengths. Okay. Based on that, it will be wins the race. And then equal strengths we are giving means conflict will be occurred. And high impedance means does not drive the signals. No one is driving the signals means high impedance will be getting. So these two are avoided. We need to avoid these two, and these two signals are allowed because one is having high strength, one is having less strength. That is also allowed. Okay, and then same signals but different strengths are means that is also allowed. Okay, see, supply 0, pull 0. Who is stronger one here? One is OR gate and other one is AND gate. Okay, supply 1 is the strongest one compared to pull 0. Okay, then this one will the wins the race. But compared to strong one and then supply 1, who is winning the race here? Strong wins the race, right? Because strong is the highest priority. No, supply is the highest priority. Okay, so supply is the highest priority, strong is the next priority. So then obviously wins the race by supply only. So remember, supply is the highest priority. Why I am doing means VDD and VSS. Okay, so VDD and VSS is the highest priority. So these are the power supply rails. Okay. So supply voltage VDD and then ground voltage VSS. So both are supply. This is supply 1 and this is supply 0. Okay. This one is the strong, and then after that, sorry, this one is the more strength. Okay. Don't use strong because strong is also having the some construct here. Okay. So then my construct is strong is the weakest strength here. Okay, supply is the highest strength. Okay, so then here what will be the winning the race here? Supply. That means OR gate we are getting the output and AND gate is not driving that. Okay, so default strengths, what is that? Here assign is the more stronger. Okay, and then pull up. So pull up is the pulling strength only, and try reach is the medium capacity. Supply net is the maximum supply conditions we are using. Supply 0 or supply 1. Okay, so just default strengths. Pull you are giving means that value you are not assigning means then pull is the output we are getting. Okay, and then strong 0. So assign statement you are giving, and what is the output you are defaultly we are getting means strength only, like strength 0 or strength 1. That means whatever the strength you are giving, right? Supply 0 or supply 1 or strong 0 or strong 1, that strength only we are getting the output side. So that is the default strength. And pull up is having pull up 0, pull up 0, pull up 1. So our pull up resistance we are having at that time also pull 0 or pull 1 is the default strength. Okay, and then try reach is the capacitive strength, that is the medium capacitance. That means storage values we are having. Either we are getting either unknown value or high impedance value. In that try reach maximum we are getting the high impedance value when we are not giving any value. Okay, so that is the try reach. And supply nets are also default value, either like supply 0 or supply 1. Okay, so like how we are remembering the wire default value. What is the wire default value? Wire default value, what is the value? If you are not driving anything on a net or wire, you are getting high impedance value. Okay, what is the reach default value? Unknown value. Okay, remember that. Z will be for wire, unknown for register. Okay, so nets are more stronger. Okay, here we are driving the wire, that is the more stronger value. So that is the most important rule in our Verilog. And then high impedance means no driving signal. That means does not affect the signal, but we are not getting any signal. Unknown error is the problem. So equal strengths, opposite values we are driving means unknown value we are getting. And then supply is the strongest compared to that represent powers. So I told you, so represents the power, right? So VDD and VSS, that is the reason supply is the more strongest value. Okay. So this is the module value I want to test here. So just tell me what is the output we are getting here. So assign strong 0, strong 1, weak 0, weak 1. My bus is driving 1 and my bus is driving 0. Okay, what is the output I am getting here? So strong means what is the output? 1 we are getting the output because the bus is storing the output value. Okay. So this is the summary, you can read that. So equal strengths we are having unknown value, and then this is the different strengths, supply, strong, pull. Maximum we are using supply, strong and weak. Okay, these strengths we are utilizing most of the designers. Okay, so just I want to show you the output here. Hmm. Just tell me, is that my screen is visible? Just tell me what is the output we are getting in the first one. So strong is the output we are getting, right? That means output 1 we are getting. And then that is the strong versus weak signals. Then here weak 1, strong 0, strong 1, weak 0. Who is wins the race here? So that means assign statement output we are getting, y is 0 we are getting, right? And then again strong versus weak. So weak 1, weak 0, strong 1, strong 0. Who is wins the race here? So 0 we are getting, right? And then strong 0, strong 1, strong 1, strong 0. Okay, who is getting the output here? Okay, so just I am running the output. So output y, x, z. Okay, what is the outputs we are expecting here? Is that running? Okay, check this condition and then run that output. Okay, what is the output you are getting? Just check that. So I will check that once it is running. Okay, so before our completion of class, we will check that. Okay, it's taking time because net is not much speed, so that is the reason it's not running properly. Okay, next one is generate block in our Verilog. What is the use of generate block in Verilog? Okay, most of the times we are repeating the loops, right? So I want to print some value many times. Okay, what is the thing we are utilizing? We go for the for loops, right? But ultimately for loops are not synthesizable codes in our RTL. Then how can I repeat the variable? How can I repeat the code in multiple times? So this generate block will repeat the block. Okay, whatever the code you are writing, so that will be repeated multiples of times. Okay, generate block is a Verilog construct. So it will generate hardware automatically based on your simulation. Before the simulation start, it will automatically generate the hardware. Okay, suppose I want to build an AND gate. So what is the AND gate output we are getting? What is the AND gate output we are getting here? So AND gate output I'm getting like this. Suppose y equal to a and b, I'm getting the output, right? Okay, so this a and b values I want to repeat four times, right? A equal to 0, b equal to 0, a equal to 1, b equal to 0, a equal to 0, b equal to 1, and a equal to 1, b equal to 1. Okay, these many times I want to repeat this block, right? So then instead of repeating that, I will use the generate block. So this generate block is used for if and case, because case is also having multiple values. For single value I am giving, I will select multiple values during the case condition. And if condition also, if I am giving some condition, okay, if the condition is true and displaying the some value, and if it is false, go for the alternate path, right? That is the if condition. And in for loop also, we are repeating many times. Before that, this generate variable we need to consider. Okay, gen var, so something, the keyword called gen var, so generate variables. Okay, so we need to repeat multiple times. Okay, so this is the generate variable is the using things. Okay, generate block do not run the during simulation, because so for loop all these things are during compilation time it is not checking. Okay, so after the compilation it will go for the simulation, right? So that is not running in the simulation. Before that compilation it will check that. During the compilation elaboration or compilation phase only it will check that is there any errors we are checking. Okay, compilation time it checks the syntax errors, all these things. Okay, if there any syntax errors it not go to the simulation phase. Okay, simulation will check the functionality of your design. Okay, whatever that RTL you design, okay, in that I need to check the functionality. What is the functionality here? Suppose y equal to a and b, this is my functionality. Assign y equal to a and b, that means and operation we are doing that. This operation is doing properly or not, the simulator will take care of that. Okay, and then this y equal to a and b, you forgot to put the semicolon here, then during the compilation time is it this will appears. Okay, some syntax error in your code. Okay, whatever the hardware you are design, that hardware I am getting some syntax error. Okay, so that is the reason I am considered here. Okay, see, generate blocks are why important. So because I need to repeat my code multiple times, at that time this generate variable will gives you. So without generate loop, okay, without generate, see, RTL is very huge to maintain, right? So I need to write multiple if else conditions or multiple for loop conditions. I want to repeat my blocks for the multiple times. Then without generate loop we can't repeat more than one time. If you repeat one time more than one time means you may get some conflict. Okay, that gives you multiple drivers are driving the same code. Then I don't know what type of output I'm getting. Suppose in your design side some multiplexer you are designing. Okay, so in multiplexer designing means y equal to what is the output, some assign y equal to select signal and then question mark, I'm giving the output I1 is to I0. Okay, if the select signal is true, I am getting the output I1. Okay, if the selected signal is false, I am getting the output I0. Okay, so this single code will tells you the design of 2 by 1 multiplexer, right? Okay, So because select signal is the one signal, just 2 by 1 mux means one select signal is there and two inputs are there, I naught and I1. If 0 is giving, your output should be 0. If 1 is giving, that means select signal is 0, you are getting 0 output. I naught I am getting the output. If select signal I am 1 I am giving, I1 is the output I am getting. This functionality we need to repeat many times. Okay, so but it is not possible, okay, without generate variable. With the generate variable, you can repeat many times. Okay, so with the generate, you can, your reusable ports will be used, and then compact code, some parameterized hardware. Why we need parameterized hardware? Because if the parameter value you can change, then the value will be updated, right? Yesterday I told you, the width we are changing, the width value I'm changing, then width overriding is takes place, right? Dot width of some 16, that means your previous RTL is working on the width is 8 bit. Now the present RTL is working on 16 bit width. Okay, then my bits are updated, and then my output is also getting huge value. Okay, due to the parameterized module. Without parameters, I need to write again another RTL, right? So suppose you want to change the bit widths of your values, whatever the signals you are driving, those signals you are driving at the 2-bit signals only you are driving. Then someone came and then changed the 2-bit to 16-bit. Then again you need to write the new RTL, right? Otherwise you will consider a parameterized RTL means then these parameters are producing the constants. Okay, that constant value can change means then entire your RTL will be changing. Okay, for that we have different type of macros are there, and tick include files are some, compiler directories are also there, and def params are also there. Okay, define params, all these things will be implemented. Okay, see, generate is not equal to running runtime loop. I told you. So generate is the compilation time only we are running that. Okay, during simulation, it will be like a normal loop. It is working, and then generate variable before simulation only. It will check the syntax errors. So during compilation time only, it will runs that. Okay. So any other things? See, generate is the generate, genvar, and generate. Okay. So all these are keywords in your generate loop. Okay. So if we are having three types of generates, like for generate, because we need to repeat our hardware multiple times. For that, I'm using the for generate. Okay, and I want to repeat some conditions many times before going to the nested loops. Okay, nested loops condition means suppose I want to check some maximum value of three variables. How can you write the condition for that? Suppose I am having A value, B value, C value. C value, three values are there. Suppose A equal to 3 I am giving, B equal to 9 I am giving, C equal to 5 I am giving. Who is the highest value here? B. Okay, that condition I need to check that. Okay, so then A greater than B condition I have checked the first. Okay, so this condition, ternary loops are also, it is best for that. Okay, so this ternary loops are also will check the, will avoid the nested loop condition. So how can you write the if condition if A greater than B? Okay, A greater than B is the true or false? If it is true, okay, so then dollar display you can write that A is maximum. Okay, and if it is false, else if condition I am going that. So else if condition, I am checking that B greater than C. Okay, so B greater than C I am checking that, or A greater than C I am checking the condition. Suppose because A also I need to check, right? So A greater than C I am checking here. A greater than C condition, is that correct? No. Okay, again 3 and 5 is there. Okay, so then else if dollar display, if it is correct, A is maximum value. and then false means else if condition we will write. Else if, okay, what is the condition we can write? Okay, else if b greater than c. Okay, so b greater than c means what is the value? B is 9 and then c is 5. The condition is true, then you will get the b value, right? Dollar display b value we will get, and then else condition dollar display we will get c value is the condition. Then I know which one is the highest value. Okay, same way here also we can write the conditions like ternary operator. How I am using the ternary operator? A greater than b condition question mark. Okay, so then another condition I am checking that a greater than c, which one is correct? If it is correct means this will be executes. Okay, so then if it is correct means what I am getting? A value is the true value. If it is false means what I am getting here? C value. Then this will be taking as a true condition. Okay, entire condition will be true for this condition. Again, I want to go for the false condition. What is the false condition here? B greater than C. Okay, same condition I am taking. If I am taking A greater than B, if it is true, A is the bigger value. Okay, if it is false, going to the else if condition, A greater than C. So that condition also I have written here. Okay, if it is true, going to the inside another condition. Okay, one condition inside another condition, that is the nested if condition. I want to avoid this nested if condition, then I will use if generate. Okay, it will generate the same condition many times. Okay, so then case statement. What is the case statement? How we can consider the case statement? Suppose I'm taking the case value. Okay, this is the select signal. Okay, my depends on the select signal. If you take 0 0, I will get I naught is the output, or if you take I0 1, I1 is the output. 1 0 I am taking, then I2 is the output, and then 1 1 I3 is my output. Okay, so your output should be y equal to I naught or I1, I2 or I3, depends upon the select signals. Okay, this select signal is having select 0 and select 1. Okay, that is 4 by 1 multiplexer you are designing that. Single select value condition, I am selecting, I am choosing multiple values. Okay, so this same type of circuit I want to repeat many times, then go for the, what is the condition? Case generate. Okay, case generate we are using that. Same thing, generate for loops. Okay, I told you, generate for loops. What is the condition we are checking that? Okay, so generate condition, what is I'm checking here? Generate, between the generate and end generate, what are the hardware you want to repeat, you can write that. Okay, so I told you for loops are not synthesizable in our RTL, then I am utilizing this one. See, I have explained one thing. What is the integer, what is the difference between the integer and int here? In the data types, what is the difference between that int and integer? Int also 32-bit data type, integer is also 32-bit data type. Then what is the difference here? Okay, so int is the normal data type. Whatever the int variables you can take that. For that purpose, I am considering the int. And then this integer, I want to count my loops. Okay, whenever for loop you are using, at that time integer I will take here. Okay, this integer I will defines you whatever the variable you are utilizing in your for loop, that will identify that. Okay, so loop counting purpose I am utilizing the integer. Okay, same way gen where I we are using the loop counting purpose. Okay, so gen var of I we are writing here. Okay, so gen var I, that I is a variable inside the for loop. I am representing the I, right? Suppose in normal Verilog you are not representing this integer I, then this is not written in your code. Then what is the syntax for loop? So for int I equal to 0, I less than 10, I plus plus, in this way you need to write. So inside the for loop only you need to write the int. Okay, then it will automatically take that integer I. If you forgot to write int inside the for loop, then you need to write the integer I at the module level. Okay, then your for loop will be repeating. Remember, I told you many times. Just go for the data types and listen that data types is that I have explained or not. You can check that. So this is the generate loop. Okay, so that is the replicating times real replicated hardware. For that we are using this generate block. Okay, so then see, I told you AND gate operation, y of 0, y of 1, y of 2, y of 3. Okay, without generate loop I need to write all these conditions. Okay, so with generate loop, what I am thinking, what is the condition we need to write? So just for loop we will write, then y of I equal to a of I and b of I. Then simulator will automatically take all these conditions. Okay, y of 0 equal to a of 0 and b of 0, y of 1 equal to a of 1 and b of 1, y of 2 equal to a of 2 and b of 2. So here I value will be repeating here. I less than, my size is depends on 4, right? Here generate variable we are using. Okay, parameterized class I am utilizing, this parameter is 4. Okay, n equal to 4 I am utilizing. Then 0 less than 4, condition true, then a of 0 b of 0 will be getting. Then I value incrementing, 1 less than 4. Okay, then a of 1 and b of 1 we are getting. Okay, so then similarly a of 2 and b of 2. Okay, a of 3 and b of 3, up to this loop terminates. Then this will be repeating many times based on the loop, like simple loops only, but the keyword is generate we are using. That's it. Same thing, full ladder also. Okay, without generate loop, how can I write the full ladder? A and B. So A, B, C, I am taking the three inputs, sum and carry, I am getting the output. So my sum output is A XOR B XOR C, and carry output is A and B, A, B and B, C and C, A. So this output I am getting, right? Okay, only I am writing the sum here, and then C out we need to write for that, means A, B, or okay, so A and B, or okay, B and C, or C and A, this output you are getting at the full ladder. Okay, check that. Okay, for generate conditions, how to utilize this? So same thing, previously I have written the AND gate, right? Same thing here also we can write. Okay, so just write the parameterized class here. Okay, hash you can take that. So parameter you can take n is equals to 8, because full ladder 8 values we need to take that, right? Then a b c values, 3 values, n minus 1 down to 0, n minus 1 down to 0. Okay, so n minus 1 down to 0 you need to consider, means 8 minus 1 down to 0, that means 7 down to 0. The hardware will consider that 8 bits. Okay, so this can also you can execute by using generate variables. Okay, same thing if condition, if also we need to repeat some condition statements. If a greater than b, a less than b, or all these things we need to repeat for that. That is the generate case for if condition and else condition. So this is the full ladder circuit I told you. So with generate conditions, he is considering if condition he is taking. If full means it is taking the sum output. Okay. So if it is not full, and then half adder is considering that. Okay. C out equal to sum output is the A XOR B, and then carry output is A and B. What is this condition? Half adder. Okay. He is operating the full condition. If it is full operation, I'm taking the full adder circuit operation. Or if it is not full, I'm taking the half adder. So for one condition, I'm operating the two circuits. Okay. So one condition I'm operating the two circuit. One is the half adder circuit and other one is the full adder circuit. Full ladder equation is wrong here. Okay, A XOR B, B XOR C. The system is not generating the XOR symbol, so you can take the condition like A XOR B XOR C. Okay, so sum output is A XOR with B XOR with C in. Okay, or you can take that. So this circle is not taking by the simulator. Okay, A XOR with B XOR with C in, but this hardware representation is wrong. Okay, how we can represent the XOR symbol? Cap symbol. Okay, A cap, B cap, C. This is the sum output. Okay, and then carry output is also not given here. Then C out equal to AB, and that means what is the C output I am getting here? A and B. Okay, or B and C. Okay, or C and A. Okay, this is the carry output. And you can don't take the concatenation operation here. So if you are taking the concatenation means both sum and carry are combined together. Okay. If you take the assign output individually like assign, okay, sum equal to A XOR B XOR C in, and assign C out equal to A and B, or B and C, or C and A. Okay, in this way you need to consider that. Clear? Concatenation means you need to write some outputs combined together, then you can go for the concatenation. Suppose during the output time, how I want to write, suppose A equal to 4 tick B 1011, this is my output, and then B equal to 4 tick B 1100, this is my another output. I want to get the output like A comma B output I want to write. So then go for the concatenation. Okay, at that time we'll use the concatenation. So if you are using the concatenation here, then one is sum output, the first part is sum output, and then second part is the carry output. Based on the order you need to consider. This is my MSB and this is my LSB. During MSB, carry output I am having, and during the LSB side I am getting the sum output. Okay, you can also consider that, but you need to represent two outputs differently, right? So for single output, so he is considered the full ladder, sum and carry are both are same, but in real hardware not like that, right? Okay, so sum output is different and carry output is different. Suppose sometimes we are writing some triple carry adder. Okay, at that time my sum and carry will be getting the same time. Okay, at that time you can use the concatenation. Suppose triple carry adder, how we can add that triple carry adder? So this is my one full adder and this is another full ladder. Okay, A B inputs I am giving. Okay, I am getting the sum output, and previously carry input is 0, I am taking that, and then next carry I am getting the output here. Okay, that will be acting as an input to the next full ladder. Okay, at that time I will concatenate my sum and carry. Okay, because 1 plus 1 you are adding, then one output is the sum output is 0 and carry output is 1. I want to take combinedly the two outputs. At that time you can concatenate them. See, I told you now. So if full equal to 1, compiler takes that full adder hardware, and then else condition it goes to that half adder circuit. Okay. So if you are not giving any value, does not exist. Any value is not existing. Okay. Unused hardware is does not exist. Okay. Same way, case statement. Multiple configurations purpose we are using that. So multiple configuration means what? So single value, okay. So multiple values I want to choose. At that time, case construct we are using. Okay. See, case you can write the type and zero. So some valence multiplier he is taking. One output is taking from valence multiplier, and other one is Booth's multiplier, and other one is array multiplier. You know the difference between the valence multiplier and Booth's multiplier? Okay, just check that Booth's multiplier is multiplying the two variables and then combining that values. Okay, so valence multiplier the carry also adding that. Okay, just check the valence multiplier and Booth's multiplier. Booth's algorithm you know, right? So in your BTech time you will study the Booth's algorithm. Hmm. I think computer architecture. In the computer architecture, so some arithmetic operations will be there. Okay. So valence multiplier and Booth's multiplier in the computer architecture and organization CAO subject is there. Okay. So in that it is available. Maximum I remember that. Okay. So just check that. Same thing. Where we are using this different flip-flops we are using D flip-flop we are using. So how the D flip-flop is generating by using this genware. Okay, array I want to D flip-flop array I want to generate here. Okay, so then parameterized class I am utilizing here. 8 times the D flip-flop will be repeating. That means one register I have designed. Same D flip flop 8 times you are concatenating means 8-bit register you form. Then that is the purpose we are utilizing this generate variables. Okay. So summary can take care of that. So this sequence detector you already know how to detect the sequence. There are two types of techniques are there: overlapping techniques and non-overlapping technique. Overlapping technique means same sequence. Suppose 1010, I want to check the pattern. So 1010. So first pattern is taken, and then next pattern, this one side only it is considering that. So one is also 1 bit, and the next bit is 0. Then pattern will be detected. Okay. So in that way, I need to write the some pattern detection. So we have two types of FSMs like Murray and Mealy. Okay. So Murray method it only depends upon the input, does not depends on the state. Okay, and then Mealy it depends upon the both input and states also. Okay, so most of the cases we are taking the Mealy method only. Okay, so just consider I told you already this pattern detection during my digital class. Okay, so just check that. uh, See 1010 I want to detect my pattern. So then first one is no bits are matching. Okay. So 0 bits are matching. Then 1 is there. Then state 1 I want to write that. And then next bit is 0. Then state 10. And then third state is state 101. Then fourth state if it is detected automatically I am getting the output 1. Otherwise it is going to idle state. Okay, so that is the basic thing in the pattern detection here. So two types of techniques I told you. Overlapped means so reuse the bits. That means same bits I want to reuse like this way 1010 pattern I want to detect it. Okay, so then next bit is where I want to detect here. So this bit I want to detect means 1010 and then 1010. Then this pattern is repeating again. Okay, or 10101 you want to detect it. Okay, so at this time 1 is also I want to take. Next bit is 1 means So this bit is considered 1 and then 0, 1, 0, 1. Suppose 1, 0, 1, 0, 1, 0, 1, 0. So 1, 1. In this way you are detecting the pattern. Then this pattern is one pattern and this is the another pattern and this is the another pattern. Three patterns we will detect. Okay, the pattern will be repeating. So overlapping. Suppose 1 0 1 0 1. Okay, 1 0 1 0. Sorry, 0 1. Okay, 0 1 0 1. Okay, so then 1 0 1 0 1. Okay, how can you detect this? Means so 1 0 1 0 1 one pattern, again 1 0 1 0 1 is the another pattern, and again 1 0 1 0 is the another pattern. In this way, overlapping technique will be considered. See, means 1 0 1 0 1 is the one pattern, and then same bit will be considered here 1 0 1 0 1. Actually, 4 bits only is taking 0 1 0 1, but previous bit also is considering. Okay, that is the overlapping parity detection. See here how he is detecting that. So I got the 1 here, then 1 0 1 0 1 0 1 0, two patterns will be detecting. Okay, okay. So that is the sequence detector. So melee sequence detector, step by step. I know you know that step 1 state 0 no match, state 1 got 1, and then state 2 1 0, and state 3 1 0 1. So how the transition will be happening. Okay, state diagram you need to write in the S1 state. Okay, if you are giving the 1, it is moving to state 1, or it is staying on the same state 1 0. This is the S naught, right? You are giving the 1 means okay, it is going to S1 state, or it is, if you are giving 0 means staying on the same state, and then S1 state input you are giving 0 means staying on the sorry, input 0 you are giving means S2 state it is going there. 1 you are giving means staying on the same state. S2 is also same that. So if you are giving 1 means okay, 1 0 1 it is moving to S3 state, or it is staying on the same state S not only. Okay, so if you are giving 0 means sorry, S2 only it is sorry, if you are giving 0 means again it is going to S naught state. Why it is going to S naught state here? Because my pattern is 1 0, and then 0 you got that 1 0 0 is the wrong pattern. That is the reason I am going to again initial state. Okay, if I am getting 1 means S3, I will go that. So if S3 0 is detected means 0 is giving means your pattern is detected. Okay, you are getting the output. If 1 is giving means again going to S1 state. Why it is going to S1 state? Because 1 0 1. Okay, again 1 0 1 means same pattern we are getting. If 0 you got means your pattern is detected, or you got 1 means again going to S1, or you are giving previous one S2 state, you are giving the 0 means going to S naught state. Okay, that is the reason. Okay, check that. So this is the summary, and then you need to check the Verilog classes, all the classes, and listen. And tomorrow onwards, I will start the codes. Okay, so before that, I will share some codes with you.